Hello friends, welcome to my channel. Let's have a look at problem 1101 together. The earliest moment when everyone become friends. So in this video, we're going to share a solution based on disjoint set data structure. So this problem asks to return the earliest time for which every person became acquainted with every other person. If there's no such earliest time, return -1. So here a remark may be that friendship is actually an equivalent relationship. A relationship is called equivalent and means that it's reflexive, symmetric, and transitive. Reflexive means that a person is his or her own friend. Let's take this for granted. Symmetric means if A is a friend of B, then B will be a friend of A. And transitive means if A is a friend of B and B is a friend of C, then A is a friend of C. So with that said, let's look at the method. The method, as we mentioned, is disjoint set data structure or UniFind. So the main point in this problem, or a main point, may be how to determine the time, right? For this, actually we just need to sort the logs according to chronologically time, and then we're going to use the find method to form clusters, and we use union method to merge clusters. So within each cluster, people know each other, and finally we just need to check if all the people can form a single cluster, meaning that each two people know each other. So when we do the reset of time, so if we found that there is no real union operations, so we are going to remain the time without update. If there are genuine union operations, we are going to update the time. So that's the main idea. Let's look at a walkthrough. So this is corresponding to example 2 for n equals 4. So in example 2, the logs is already sorted according to the first element in each of its element list. For example, 0, 1, 3, 4, 7, which represents time. So when we look at the first log item, so time is 0. So in this case, person 2 and person 0 know each other. So with the result is 0. When t equals 1, so we look at this one. So 2, 0, 1 become friends. So because there are genuine union operations, so we union 1 with the 2, 0. So the result is reset to be 1. And when we look at the third third log, so there is genuine union operation. So we merge 3 with 2, 0, 1. So we set the result by the current time 3. That is result equals 3. So when we look at the next log corresponding to timestamp 4, so there is no genuine union operations. So all people know each other. So there's no update in the result. So when we look at the last log item, so corresponding to timestamp 7, so all people know each other, no update or union in the result. So finally, we are going to check if the cluster contains all the people. So here it contains 0, 1, 2, 3, all the people. So we are going to return 3. So that's the earliest time. So with this walkthrough, so let's look at the code or solution. So here we're going to implement the disjoint set data structure within the solution function. So for that, I'll divide this into different steps. So first step is basically an initialization for the data structures or the UniFind. So let's initialize a root, roots, and also we want to initialize a rex. So here the root, because we have n person, labeled from 0 to n minus 1. So we're going to use I for I in range m. So initially, each person is his or her own root. So the rank is easy to set. So for I in range m. So initially, each person forms a cluster. So the cluster size is 1. So here, rank means the cluster size. So with that said, we are ready to write the hyperfunctions. So the hyperfunctions basically are the union find functions. So let's first implement the find method. So given a person I, so let's find its root. So we're going to introduce a variable called result. So then we're going to do a while loop to check if result and its root are the same. So if they are not the same, so we're going to iterate. So basically it's corresponding to set this result to its root, then do the while loop. So in between, we would like to accelerate a little bit by path compression. So it's corresponding to set the root of the result to be the roots of roots result. So here I'm using twice of the roots. You can use more times just for fun, but this plays the role. So after we exit the while loop, we're going to have a state that is result equals roots of result. Then we're going to return result. So that's the find method with path compression. So next, let's look at the union method. So we want to merge two persons. So for this, we're first going to track their root, R1, R2, corresponding to the root of I and J respectively. Then if R1 equals R2, it means that I and J are already in the same group, so no genuine work needs to be done. Otherwise, we want to reset the root relation and merge the clusters. So if R1 does not equals to R2, then we want to do the merge according to the rank. So we are going to track the information of ranks. If ranks R1 is greater or equal than ranks R2, then we're going to set the roots of R2 to be R1. And then we're going to increment the cluster size represented by R1 by that of R2. So ranks R1 incremented by ranks R2. So otherwise, we are going to do the same thing, but in a reverse direction. So let's copy these two lines and then put it here and then modify. So we set the roots of R1 to be R2, and then we are going to increment the size of cluster represented by R2 by that of R1. So that's about it for this union operation. So as we mentioned, so we want to check if there is genuine union operations or not. So for that, we want to check if two people know each other or not. So this basically checks if I and J are in the same clusters, So we're going to return find I equals find J, right? So that's about it for the main hyperfunctions. So next, we're going to do the real work. So for that, first, let's sort the logs. So notice that the logs is not necessarily sorted as in example 1 a priori. So we need to do this is a crucial step. And then we're going to do the merge. So for that, let's first introduce a result. So let's make it none first, and then we are going to traverse the logs after sorting it. So for time and person 1, person 2 in logs. Then we're going to check if the two persons already know each other. If known, P1, P2. So no genuine union operation. We just need to continue, and also no reset of the result. Otherwise, we're going to union P1, P2, and then we reset the result to be the current T, because current T is the nearest. So with that said, we are ready to make the return. So let's see, return. So first we need to check if all the people know each other. In other words, we want to check if all the person have the same root, right? So then this can be easily checked by, so if we make a set for this one, find I for I in range n. If all the persons have the same root, so this set will have only one element. So we're going to check the length if this length equals 1. So let's see, length. So if so, we're going to if length, let's see, let's copy this one. If length this equals 1, we're going to return result. Otherwise, we're going to return -1. Let's see if this is the right length set. So here is 2 braces. Set. Okay. Yeah, that's about it for the solution code. I guess now it's time to test a special case. Oh yeah, it passes example 1. Now let's do a generic case check. Let's do it again. Yeah, it passes all the generic case. So I guess for this problem, we first implement within the function a union find data structure, and then we sort the logs and then perform the time reset, and finally we check if all the persons form a single cluster. If so, we are going to return the nearest time. Otherwise, we're going to return -1 according to the problem statement. So with that said, I guess it's about it for this video and for this specific solution. Thank you very much.